Okay, here we go. 2-1. If-then statements and converses. So objective 1, 2, and 3. The warm-up, we're gonna talk about this later. So we're gonna come back to this. Okay, let's go to the first page. Okay, here is what we have in chapter 2. We have 6 sections, and we will probably do a quiz here, and then a test here. Okay, we will start writing proofs in chapter 2. Okay, here is 7 objectives for the first 3 sections. Okay, and then 1, 2, and 3 are in 2-1. Okay, so objective 1, recognize the hypothesis and the conclusion of an if-then statement. Okay, so conditional statement is the same as if-then statement. Okay, so your friend says, if it rains after school, then I will give you a ride home. A geometry student reads, if B is between A and C, then AB plus BC equal AC. Do you remember what this is? Segment addition postulate. Okay, these are examples of if-then statements, which are also called conditional statements or simply conditionals. To represent an if-then statement symbolically, let P represents hypothesis, shown in red. Well, you can't see it here, but anyway, this is the hypothesis. Let Q represents conclusion, shown in blue. Then we have the basic form of an if-then statement shown below. If P, then Q. If hypothesis is true, then conclusion is also true. That's what this means. If P is true, then Q is also true. If this statement is true. Okay, so here are different forms. This is where it gets a little bit confusing. Conditional statements are not always written with if clause first. Here are some examples. All these conditionals mean the same thing. Okay, so if P then Q, this is the standard form. If x squared equals 25, then x is smaller than 10. If this is true, then x have to be smaller than 10 because x squared is going to be 100. So you have to be smaller than this. P implies Q. These are the same. X squared equals 25 implies x is smaller than 10. I think these two are okay. These two are pretty intuitive to me. The problem is these two. It's not very intuitive English-wise. P only if Q. This is the same. The hypothesis is this, and conclusion is this. This is still if x squared is 25, then x is more than 10, even though this follows f. And this, the hypothesis is following f. This one, the conclusion is following f. So this is, to me, this is the most confusing. But you have to remember these three, always the hypothesis first, conclusion first. And to complicate the thing worse, there's another one. If there's just one if, then conclusion and hypothesis flips. P if Q. X is smaller than 10 if x squared equals 25. Now, to me, this is better because hypothesis is following f, even though the order is flipped. So if this, then this. Okay, so this is the only one. The order is flipped from the. This is the this is the conclusion, and this is the hypothesis. Okay, and this one, the conclusion is following if in this one. Okay, so here are ones that you have to identify where the hypothesis and conclusion are. So the hypothesis usually follows if. So this is the hypothesis, and this is the conclusion. Okay, don't include the then and if in hypothesis and conclusion. It's what follows these words. Okay, so you can do this one. Okay, homework. And you can do this one. Homework. And all right, so let's look at this one. RS equal 1/2 RT. This is one of the theorem that we're gonna do later. This is midpoint theorem. But anyway, RS equal 1/2 of RT if S is the midpoint of RT. In this case, there's just one F, and this is what's following. So this is the hypothesis, and this is the conclusion. Okay, so this is the one that order is flipped. And here, you can do this one, homework. Okay. All right, let's look at this one. So this is the only F1. So what follows if in this case is the conclusion, and before that is hypothesis. So this is the hypothesis conclusion order, like these ones, but the only thing is the what follows if is conclusion in this case. All others, what follows if is hypothesis. Objective number 2 is the converse. So state the converse of an if-then statement. The converse of a conditional is formed by interchanging the hypothesis and the conclusion. Statement or conditional is if P, then Q. P is the hypothesis, Q is conclusion. The converse is if P, then Q. What was conclusion in conditional become the hypothesis, and what was hypothesis in conditional become the conclusion. Okay, so it's flipped. A statement and its converse say different things. In fact, some true statements have false converses. Statement: if Ed lives in Texas, then he lives south of Canada. False converse: if Ed lives south of Canada, then he lives in Texas. You know this is not true, right? So this is a true conditional, and this is false converse. Okay, all right. Objective number 3, use a counterexample to disprove an if-then statement. Okay, so you know that this is not true, but to prove that this is not true, you have to come up with an example that make this sentence incorrect. So here is an if-then statement is false if an example can be found for which the hypothesis is true and the conclusion is false. Such an example is called counterexample. It takes only one counterexample to disprove a statement. We know the converse above is false because we can find the counterexample. Ed could live in Kansas City, which is south of Canada, which is the, for the converses, the south of Canada was the hypothesis, which is true, but the conclusion is incorrect. Live in Texas is not correct. Okay. All right, so let's practice here. You come up with counterexample for this. If segment AB is congruent to segment BC, then B is the midpoint of AC. What do you think about that? What's the counterexample of that? That this disprove this? This sounds kind of correct. I know you're thinking this sounds correct. But here's a counterexample. Let's see, make sure you can see it. Here's A, here is B, and here is C. So A and B are congruent because they are same length, but B is not midpoint of AC. Midpoint of AC would be over here. Okay, so that's a counterexample for number 8. Okay, I think you can do these for homework. Okay, all right, objective number 4 is understand the meaning of if and only if. Okay, if and only if is called biconditional. Biconditional statement. So, some true statements have true converses. You remember the south of Canada? The converse was not true. But some statements have a converse that is also true. Meaning if 4x equal 20, then x equal 5. That's a statement. So this is the hypothesis. And that's the conclusion, right? Don't include if and then in these. Okay, you're going to get a test on underlying hypothesis and conclusion. So, and the converse would be now the conclusion is hypothesis and the hypothesis is conclusion. If x equal 5, then 4x equal 20. This is still true. So this is true conditional and this is true converse. If both the conditional and the converse are true, then you can combine them into biconditional in this form. If a conditional and its converse are both true, they can be combined into a single statement by using the words if and only if. A statement that contains the words if and only if is called biconditional. Its basic form is shown below. Every definition can be written as a biconditional, as the statements below illustrate. Okay, so this is how definition of something can be written, because for something to be a definition, both the statement and converse have to be true. And then you will see the example of this so you understand better. Okay, so the definition here. Congruent segments are segments that have equal length. This is the definition of congruent segment. You remember the equal length is congruent segments? So here's the biconditional. Segments are congruent if and only if their lengths are equal. Segments are congruent if and only if their lengths are equal. And you can write this. So this is segments are congruent is the hypothesis, right? And only if, that's the conclusion. And since this is the true biconditional, you can flip this and it's the same thing. The segment have same lengths, have equal lengths. If and only if they are congruent. See, that's true too, right? So the biconditional, you can flip the converse, conclusion and hypothesis, and then it's still true. And that's how the definition, this is the way to check to see if a definition is true. If the converse is incorrect, then that is not a definition. Okay, so here is a practice for you to write this into biconditional statement. State the converse of each conditional, its converse true also. Okay, so this is to see if the converse is true or false. And if the converse is true, restate the sentence in the biconditional form. Okay, so let's do one of these. Okay, one that is not true converse, and then one is the true, the converse is true. So let's try this one. 12. If today is Friday, then tomorrow is Saturday. Okay, so what's the converse here? Write the converse. So you flip the hypothesis and conclusion, right? So right now, this is the hypothesis, and that's the conclusion. So the converse for 12 is if tomorrow is Saturday, then today is Friday. Is this true or no? Is this statement true? Is this converse true? Converse. Tomorrow is Saturday, then today is Friday. It have to be true, right? That's a true converse. And therefore, you can rewrite this into biconditional. So the biconditional would be if, no, today is Friday. Friday. If and only if tomorrow is Saturday. That's the biconditional. Or you can write this too. If, no, not if. Tomorrow is Saturday. If and only if today is Friday. Okay, so that's biconditional. Both are correct. Okay, either way, it would be a correct answer. And let's try the one that is not true. So let's do number 13. Okay, so if x is greater than 0, then x squared is greater than 0. So this is hypothesis, and that's a conclusion. So first of all, let's think about this. Is this correct? Is this conditional correct? The conditional says if x is greater than 0, then x squared is greater than 0. It is true, right? It have to be true. So that's a true conditional. How about a converse? Write a converse. Write yourself first. So you flip the hypothesis and conclusion. If x squared is greater than 0, then x is greater than 0. Is this a true converse? Is this a true converse? That's the question. Stop the video and think about it. Alright, is it true or not true? It's not true. So what's the counterexample? When you say it's not true, the statement, the converse statement is not true, you have to have a counterexample. So the good counterexample would be x equal -1. Okay, so the x squared would be 1, which is greater than 0. But x -1 is less than 0. So that's a counterexample. Okay. So now you cannot write this in true biconditional because it would be incorrect. Okay, so you do 14, 15, and 16 as a homework. Okay, and I want to go back to the front. And so here is a conditional that I wrote, and these are true statements. If it is Monday, then Miko has her violin lesson. Miko is my 10-year-old daughter. And today is Tuesday. And I want you to think about what do you think is the conclusion of these two statements. Both of these statements are true. Okay? And let's assume we are doing it on Tuesday. And what can you conclude from these two statements? I want you to think about that, and we talk about this in the class. Okay? All right, we are done for today's video. Make sure you do the survey.